We're going to multiply polynomials today. I'm only going to take you through part of this section, and we're going to be working on the packet number 3. You should have received this in the emails from me. Okay, we're only going to go through half of it today. The rest of it will continue on Monday. Okay, the rules for adding and subtracting polynomials is different than multiplying and dividing. Okay, let's just put an example up. Let's say 3x squared y times 4xy cubed. Okay, this is a term and this is a term. Again, we just have 2 of them. This is not necessarily a binomial, because binomials and trinomials and polynomials are separated by the pluses and the minuses. So this is just a problem that is involving one monomial and a monomial, which I don't know if that's a really big deal for what you're going to need to know. But this isn't a binomial because there's not a plus or minus there, is what I'm trying to get to you. Okay, when we multiply, I really kind of like multiplying because all you do is get the common, I better not say common terms. You're going to look first at the coefficients, which are the big numbers, multiply those because it says to multiply. So I get 12. Then we're going to multiply the x's. This one has 2 x's multiplied together. Do you see? Because x squared. And this one has another one. So when we put these all together, we have x cubed. Now that follows the exponent rule that says if I'm multiplying same basis, I add the exponents. Do you remember the exponent rule that says that? If I'm multiplying same basis, then I add the exponents, the 2 and the 1. I'm only dealing with the x's right now. In multiplication, you can pull these things apart. You don't have to have common terms anymore. Now that we've taken care of the x's, now we're going to take care of the y's. So when I multiply y to the first times y to the third, what do I have? 4. Y to the 4th. And this, ladies and gentlemen, is the answer. We simply multiply the coefficients, multiply the x's, the y's, the ABCs, whatever. Do each piece separately, and that will be the answer. Okay? So let's look at some on your worksheet, because I know that some of you probably looked at it already and said, but there's fractions. So
that's what I said too.
So let's look at number 1 on page 1 of this packet. And we'll just do that. For those of you on remote, number 1 is right here. I'll put it on the board. 2/3 p cubed times, they use an x. Sometimes our x's and times signs get mixed up. That's why I use a different one. P to the 4th. Okay, when you look at this, we have a monomial here and a monomial here, and they're being multiplied. And so we know that we can do things separately. All this stuff is multiplied. So this is the coefficients that on this monomial and this one, we look only at the coefficients and it says to multiply them. Now, when we multiply fractions, you need to remember that too. We multiply the top and then multiply the bottom, okay? This won't have common denominators. You multiply them. So we're going to have 2 over 9. Do y'all see? When we multiply fractions, you multiply the top and the bottom. And then we have p times p times p here, and p times p times p times p here. So when I multiply all those together, I have p to the
Wow.
7th. Mhm.
Oh, okay.
Whenever you're multiplying same bases, you add the exponents. Yes. Yes. Multiplying same bases, add the exponents. And if it helps you for a while, do this. P to the third means P times P times P. Write them up there if it helps. Times P times P times P times P.
Does that
So
go for all of the exponents?
it goes, okay, ask your question again.
I said, does that go for all of the exponents on like adding, subtracting?
No, when you're multiplying.
Just
When
when
you're
you're
multiplying by same bases or multiplying same bases, like the P and the P, then you
Yeah.
just add the exponents.
Okay.
Okay, go back and look at the YouTube on the rules for exponents, okay?
Okay.
But the fraction itself doesn't have to cause any worry for you because you're simply going to multiply these. If you have a hard time doing this by hand, simply use your calculator and multiply these. The one thing that I want to get across to you when you're multiplying monomials is just do one piece at a time. Just do the coefficient, get an answer. Just do the p's, get an answer. If there are q's, then do the q's and the w's, okay? One thing at a time. So now let's look at that. How about if we go down to 8? Number 8, we can do 8 or we can do let's just go to 2. Number 2.
My goodness, Travis.
Number 2. Negative 2y times 5/6 y
Maybe.
times 9 y. Okay. So what we're going to do is look at our coefficients first. We have a negative 2. Remember to bring the sign with it. Times a 5/6 times a positive 9. Okay. So if you're not using your calculator, I make them all fractions since we have a fraction. So now we have negative 15. Did y'all do it with your calculator? I didn't get you one, Sandra. I'm sorry.
So we're simplifying those fractions right now.
Yes, you're just multiplying them together so that we can get an answer. And if I did it correctly, it should be negative 15. Did anybody use their calculator to do that?
Yes, ma'am. It's a negative 15.
Okay, thank you. Then when we're through with all of the coefficients, then we simply multiply how many y's we have. Now remember, every single variable has a coefficient. If there's not one showing, it's an invisible one. Every single variable has an exponent also. If it's not showing, it's an invisible one. So we have 1y here, 1 here, 1 here. So I have now y to the
Third.
end. So it doesn't matter how many monomials that you're multiplying together, same rules apply. Just multiply all the coefficients together and then all of the variables that are the same basis. Okay?
Easy enough.
Anything here that's confusing yet?
No.
Okay, let's go to the next page. Because believe it or not, the information that I gave you right here concludes all the new information that you need. Now I'm going to take this information and the information you know about distributive property, and we're going to put those together. So let's look. I think, well, I looked on page 2 and I'd like to do one more here, just to keep you guys from getting freaked out. I am on page 2, and I think we will do number 4 because it has an awful lot of stuff there. Number 4. Okay. 6b cubed, c to the 5th, b cubed, 1/7, 2b to the 6th, c to the 7th, d to the 5th. Okay, same rules, it's multiply. So we look at all the coefficients. This one doesn't have variables, but it's a coefficient for x to the 0. And this. So we're going to multiply all of these together. And when you do, you should come up with an improper fraction, 12/7. When you multiply those together. Now here are some b's. So let's go find the rest of them. Here's a b times b times b times b times b times b times b times. Okay, so how many b's? 9. Because I have same bases, and notice that this doesn't have to have a b in it because everything's multiplied, so it's kind of all crammed together. So here are the common terms right here. 3 plus 6 is 9. Now let's look at C's, find all of the C's. 5 of them there, 7 of them here. So I have C to the 12th, and one more time, D to the 8th.
Okay.
Any questions?
No.
How did you get 12/7 when there's, it,
It's like this. Since that's a fraction, I made everything be a fraction.
but I got the,
Nice.
Because you added that in.
I
Six-
don't know that is.
6 times 1. 6 times 1 is 6.
Okay.
Times 2.
Okay.
Yeah, yeah. 1s and 0s will trip you up all the time. Okay? But that's where I got 12/7. And the reason I wanted to do this, the rules or the steps are exactly the same. But sometimes when you look at a long one like this, it's scary. Just pick them apart. Pick the pieces apart is what I was going to try to say. Somebody told me it looks like a big old elephant in the room, but all you do is eat that elephant one step at a time, one piece at a time. Now, let's go to the distributive property I was telling you about. We're going to do number 1. This is on page 3. Number 1. Now, first of all, I want you to recognize that this is a little bit different than the last one because of this plus. Okay? This isn't times and times, so you can't go all the way across and just multiply and then go all the way across and just add the exponents. That's not possible because of the plus. Okay? You have a monomial out here, one term, and it's multiplied by this in parentheses, a binomial, because I have two terms that are separated with a plus, okay? If it has a plus in it, that's messing up your whole multiply thing. However, the distributive property says, take what's in front and multiply it by each piece. Do y'all remember the distributive property we've been doing?
Yes.
So now I'm going to go ahead and write an extra step in here. Y'all don't have to do this, but I want to show you what's happening. We're going to take this negative 2v times 15v to the sixth. We're going to do that one first and get an answer. And plus, then we're going to do it again. So we have negative 2v to the seventh times 46 v to the fourth. Do y'all see?
Yes.
Okay. And since this is multiply, then we'll do this like we did all the multiplies. This will be a negative 30, negative 2 times 15, v to the what?
Uh,
To the what?
7.
Seventh. Because every variable has an exponent. So this is what I get from this first time that I multiply. Then I have a plus. And then the next time I multiply, I'm going to have a negative 92
Yes.
v to the
11.
11th. Okay, two things on here. If you have plus and negative, this is okay. But I just use a minus for that. If you have a plus and a negative right together, it's the same thing as a minus. Are we okay with that?
Yes.
And then the last thing you're going to look at. Now we have a monomial minus another one. Do we have common terms so that we can add them together like we did yesterday? We
No.
do not have common terms. This is a v to the seventh. This is a v to the 11th. They cannot be put together. And so your final answer is just going to be, if we put it in standard form, this is the larger exponent, right? So let's put it in standard form, 92v to the 11th. And we're going to use this sign, minus 30v to the 7th. And so this would be our answer. So we mixed up the multiply and the plus. Be very, very careful. If it says plus or minus, you can't like add the exponents. You have to get common terms. If it's multiply, like here, then you can add the exponents. Okay. Just have to keep your brain popping, right? Let's look on page 3 and page 4, because that's only your first one. If you see another one you'd like for me to work, that's all I'm teaching you new today. There's some with a lot of fractions, but you all have a calculator right in front of you. So fractions shouldn't give you any trouble at all. Looking on page 3 and page 4, whatever you wish, we can do a couple more, whatever you need to see.
Can we do number 7?
On On page 4.
Yes.
Yep, that one looks nasty. Here's the one she's asking about. Right here. Okay. This is one of those that, yes, it looks completely scary, but if you do one piece at a time, you're going to be fine. Here we go. Okay, lots of pluses and minuses and fractions, not scary. Notice that every variable has a coefficient, right? This one has a -4/9. This one has a invisible 1. You always have a number in front. This one has 9/2. This one has a -18 in front. So this is a trinomial, 1, 2, 3 terms separated by pluses and minuses. And then we have one monomial that's going to be taken times each piece that's inside. So let's start slowly and easy. Let's do the first one. So I have a -4/9 times a negative. We already know that's going to be a positive. Negative times negative is positive. 4/9 times 1 is definitely 4/9. And q to the 5th times q to the 5th. Same bases, multiplying. So we add the exponents. And we have 4/9. You don't have to put this. Q to the 10th for the first one. Then we go again. This time, it's going to be negative times a positive. Negative times a positive. Do y'all see it? So it's going to be a negative. And then when I multiply 4/9 times 9/2, y'all can try that in your calculator, but I think it comes out 2. Anybody checking?
Yes.
Okay, 2. And then again, we have this and this are same bases because we're done with this. So Q and Q are same bases, so we add the exponents. Now, one of the things that people, I've seen them make a mistake on is they get really wrapped up in the 12, and so they end up putting 2 to the 12th. Make sure that you have your base. Make sure you put your base down because the 12 goes with the base.
The number was 4/9 or 14/9.
14/9?
Yeah, I did the 4/9, take away the 2.
Oh, no, you can't do that yet. We're going to continue the distributive property, okay?
Okay.
Okay, we finished multiplying this one. Now we're going to do it one more time. We take it as many times as there's stuff in the parentheses. When we get to the end of the parentheses, we can stop this. So now I have one more time, negative times negative. So I'm going to have a positive, yes. And I have 4/9 times 18, which will give you 8, I think.
Yes.
Good, okay. 8, and then we have to take care of our Q's. Make sure they're same bases, they are. Q and a Q. So when I'm multiplying same bases, I add their exponents and I'm going to have to the 11th. Okay? Then you look at your answer. Can I do anything else? So when it's add and subtract, we have to look for common terms. Yes? Are there any common terms that we can put together? No, because Q to the 10th is way different than Q to the 12th and Q to the 11th. So let's write this in standard form. And remember, standard form just has to do with the largest exponent. Here is the largest exponent, it's 12. That's why this goes first. Remember to include the sign. So I have a -2, Q to the 12th. Next biggest exponent is my 11. And I have the sign with it. Plus,
Miss Deborah, I think that 8's supposed to be a negative.
nope, this one, no,
Okay.
negative here times this negative.
I didn't see that negative sign. I put it in my calculator. I left that negative off. I didn't see it. I apologize.
You cannot get the right answer, Sherry, if you don't put it in the calculator this time.
Well, I'm
Thank you
okay.
for watching me. You know that I make mistakes. Thank you. Not here. She's supposed to take that test.
Okay, well, I was just kept thinking, I know she said yesterday.
So I'm through with this one, and of course, there's only one left, but that's the next biggest exponent. We don't go by the coefficients, we go by the largest exponent. So the last one, we're going to use the sign that's out in front. If there's nothing, then it's a plus. 4/9 Q to the 10th. So although this one that we wrote before is a perfectly
Hey, baby.
answer, it's fine, but it's not in standard form. We found out to answer all their other questions, we need to have it in standard form. So what's the leading coefficient?
12.
-2.
Oh,
Leading
yes.
coefficient, -2. It's the coefficient that leads this whole thing. What's the degree of this polynomial?
12.
The degree. 12, because it's the largest exponent. Okay, how many terms? 3. What's the name of this polynomial if I classify by terms? It's a trinomial. I think my class has done some homework. And
That's
what
what I
all this classified by degree?
Cubic.
What was the question?
Cubic. We don't have one for 12. Not cubic. We're going by 12. Degree.
Oh.
And so it'd be to the 12th.
Oh, to the 12th.
Polynomial to the 12th power. Yeah.
Oh, so Miss Deborah, okay, so it's got 3 terms, so we don't, the degree, we don't name it by the 3 terms, we name it by the number of the degree.
The degree is the exponent.
Yes.
Okay?
So I don't think you understand what I'm asking. So when we do the name of the degree, we don't say, well, the degree is cubic because there's 3 terms.
No.
We say is the,
And we don't really have a name for the 12th degree. It's just a polynomial to the 12th degree.
okay, all right. Well, okay. Well, I don't understand how I got all my stuff right yesterday because I was doing it wrong. But anyway.
You just have that magic touch, don't you?
I guess so.
Something came to my mind about that I want to make sure that you understand this piece. And then I really don't have anything else to show you. I want to release you to practice. and ask questions and struggle. You know, I tell you that if you struggle, you're learning more. This isn't off your worksheet, but I want to make sure that you understand this. If I have 3xy times ax b, okay, maybe I have this. Now these don't look like common terms, but again, you don't have to have common terms when you're multiplying. So your answer here, there's the invisible 1. You'll take your 3 times 1. And then I like to go in alphabetical order. So the first letter of A's, there's 1, and there's no A's here. So I've just got an A. And then B's, I don't have any B's over here, so this is all I have. And then X's. So this is not like add and subtract where they have to be common terms in order to use them. Whenever they're multiplied, they're just all crammed together. Everything's crammed together, so you use all of them. Okay? If they don't have the same here as the same here, it won't always be that case. Are we good? How are you all online?
Well, I thought I was doing all right till just now.
Till just now. I think you all will do great. I'm going to stay on. Remember, today's our short day, but we'll stay on as long as you want until we're through at 11:30. So you can ask questions, but I'm through with the lesson for today.